And now we do octal to decimal. We do it simply the same way we have done with the binary, in which case we say the conversion of an octal number to decimal is achieved by multiplying each octal digit by its positional weight and summing the product. And I think I gave an example, but doesn't harm to do another one. For instance, we want to do 527.26. To convert it to decimal, we just know that this is position 0, so it is 8 power 0, 8 power 1, and 8 power 2. And going to beyond the decimal to the right, this becomes 8 power minus 1 and 8 power minus 2. So we do that summation. We can say it is equals to 5 times 8 squared plus 2, this 2 here, times 8 power 1, 7 times plus 7 times 8 power 0 plus 2 divided by 8 power 1, because whenever you do negative, it is equivalent to 1 over 8 power 1 plus 6 all over 8 squared. So that is how we do it on that side. So this becomes 64 times 5. This is 320 plus 2 to power times 8 is 16 plus 7 times 8 to power 0 is 7 plus 2 divided by 8 is 0.25 plus 6 divided by 64 is 0.99375. So when you do the summation, we get this gives you 343 point. This becomes 34375. So this should be your answer. Sometimes you're going to be told to 2 decimal places or 3 decimal places, so you can be able to choose your 3 decimal places from this value. So this is how you do your octal to decimal conversion. Now we would also want to do octal to binary conversion. And we say that a number can be converted to be a binary equivalent by first obtaining its decimal value and then converting it to binary. That is one method. But a simpler method is just take each of the octal digits and you convert it to binary. That is the easiest route. So for instance, we assume we are given a number like we have already seen before. Just say 1, 2 in base 8. If you want to convert it to binary, what you need to do is what we have read here. You'd first of all need to convert it to binary decimal equivalent, and then you convert it to binary. So that method would simply means like this. So you convert this one to become 8 to power 0 times 2 plus 8 power 1 times 1. This becomes 2 plus 8 is equals to 10. So this is 12 power 8 is equivalent to 10 to base 10. And therefore, if you wanted to convert this now to binary, you do either repeated division or know that we can take the multiples of 2 or powers of 2 such that we know the highest power of 2 is 8. So this is going to be equivalent to 8 plus 2, which means it is 1, 4 is 0, 1, 1 is 0. So this is how you present number 12 in binary. So you're saying 12 to base 8 is equivalent to 1010 in binary. And notice that we had to transition to a decimal equivalent first before we did this conversion. If we just divided by 8, or if we took the positional weights of this 12, it would have given us a different figure. So that is the first method. The second method is just taking 12 as it is, and then what we are told here that to translate each octal symbol into its digital equivalent. So you say 12 has 2 digits, 1 and 2. So 1 is represented by 3 digits, 3 binary digits as 001, and 2 is represented by 3 digits as 010. Therefore, you arrange them like they are following one another, with the most significant one being on the left. So you have 001 followed by 010, which now, as you can see, this figure here is the same like we got right here. So we say that 12 in decimal 8 in octal is equivalent to 1010 in binary.